what we're going to work with is algebraic fractions and operations. Over the next 2 days, we're going to first of all start out by seeing what an algebraic fraction is and how to simplify it. And then also today, because it's a pretty natural extension, we're going to multiply and divide algebraic fractions. And then tomorrow, we're going to add and subtract algebraic fractions. We're also going to today simplify complex fractions, which are really just fractions within fractions, and it's closely related to multiplying and dividing those fractions. Now, the principles we're going to apply are all based on numerical fractions, which you're all experts at working with. So we're going to start everything that we're going to do for the next 2 days. We're going to start by looking at a numeric fraction, just a regular old fraction with numbers, and see how to work with those, and then we'll extend it to algebraic fractions. We have a fraction 28 over 32. Now, if I say reduce that, you could all reduce that, no problem at all. But what you're really doing, if you think about what you're doing when you reduce or simplify a fraction, is that you're just eliminating common factors that occur in both the numerator and the denominator. For example, 28 over 32, you could rewrite this. If you break it into its prime factors, 28 you would break into what? What? 7 times 4, but 4 can be further factored into, whoops, I said 7 and wrote 4. 7 times 2 times 2. Okay? In the bottom, we've got 32, which is 8 times 4, or in other words, 2 times 2 times 2 times 2 times 2. So you break it into its factors, and then ultimately you just look for what factors will go into both of these. And of course, we can get a pair of 2's out of both of them, or in other words, you could have just said initially, divide them both by 4. But ultimately, the reason that we can divide both of these by 4 is because we've got a factor of 4, or 2 squared, in each one of these. Now, there's nothing else that you can factor, nothing else that you can cancel, and so you're left with 7 over 2 times 2 times 2, which is the same as, of course, 7/8. Now we're going to take that exact same idea and apply it to an algebraic fraction. Factor, cancel your common factors, and you've got it reduced. For example, 4a to the 4th plus 6a to the 3rd over 4a squared minus 9. That's an algebraic fraction. Any fraction with variables in it is an algebraic fraction. Well, let's simplify that. We have to do the same thing we did with a numeric fraction. You need to factor it. You need to get it into its factorization or its prime factorization first. So we have to factor the numerator and denominator. Take a look at the numerator. Now the thing you need to watch for now the last couple days we did all the different types of factoring. Now you need to be able to just look at an expression and know which type of factoring to do. And basically we're always looking for greatest common factor, difference of squares, some sort of a trinomial, or sum or difference of cubes. So if you look at the numerator up here, what can you factor here? Greatest common factor, you can factor out a 2, and you can factor out a to the 3rd. So we can pull out 2a to the 3rd, and we're left with, over here, 2a, and here, just 3 plus 3. Now, can the top be factored anymore? No. Okay, what about the bottom? 4a squared minus 9. There's no greatest common factor, so we're out of luck there. Certainly isn't a trinomial, so what have we got to factor here? Difference of squares. Those are both perfect squares. That's a perfect square, and this is a perfect square, so it'll factor into. The first term in both of these will have to be 2a and 2a, yep. Difference of squares means we're going to have plus and minus, and the last terms obviously have to be 3 and 3. Okay, so we've got everything completely factored now. Now, since we're trying to simplify it, we're just going to wipe out any common factors. Well, what's your common factor? Those cancel each other off. And so we're left with 2a to the 3rd over 2a minus 3. And it's simplified. All right. Well, that's how you simplify fractions. We'll do another one in just a minute. But there's something that's important to note now that we're dealing with algebraic fractions. We recognized this just a little bit when we were working with domain and range and graphing. Look at that fractional equation right there. Now, what is it that you can never have in the denominator of a fraction? Can't have a 0 down there. Anytime you've got a algebraic fraction, you always have to make sure that that denominator does not end up being 0. So if you look up here, there's basically two values that would let that denominator be equal to 0. What are they? 7 and negative 3. That's right. If we have, whoops, n cubed times n cubed minus 2 over n minus 7 times n plus 3, we have to make sure that the bottom isn't equal to 0. Now, if either one of these factors turns out to be 0, multiplying it by the other one will still leave you with 0. So we can't let that be 0, so we say n minus 7 can't be 0. If it was, we'd have 0 times anything, and we'd end up with 0. So that means that n cannot be 7. Over here, we know that n plus 3 cannot equal 0. So subtract 3 from both sides, and we see that n cannot equal negative 3. So those are your two restrictions. We say those are two restrictions on n. Now, at this point, there's no real significance to that other than recognizing it. But later this week, or early next week, we're going to be solving equations that involve algebraic fractions, and these are basically forbidden solutions. If we find an equation, or if we have an equation, one of the solutions turned out to be 7, for example, we have to ignore it. It can't be a solution because it's a restricted value, and cannot be 7 if you're dealing with this fraction, nor can it be negative 3. What about the top? Any problems with the top? It's no trouble. Numerator of a fraction can be 0. That's no problem. It's only the bottom that we pay attention to. So let's go back to for just a minute. Getting ahead of myself here. It's just worth noting that any value of a variable that would result in a 0 denominator has to be recognized as a restriction. So let's go back to one of the algebraic fractions that we simplified just a minute ago. There it is. Now, we already factored this once. We factored it up, and we found that this was equal to, before we canceled, 2a to the third times 2a plus 3. This is already in your notes. 2a plus 3 over 2a plus 3 times 2a minus 3. Let's go back to this example which we already worked with and recognize what the restrictions are. Now, these, they don't jump out at you like the one I just showed you. These take a little bit more work. We have to take each one of these factors and set it equal to 0 to find out what the restriction given by each factor is. So if we start out with this one, we have to recognize that, okay, this factor of 2a plus 3 cannot be 0. So if we solve that, we find out that 2a cannot be equal to negative 3. Divide by 2, and the restriction from that factor is that a cannot be equal to negative 3 halves. If a was negative 3 halves, then this factor would turn out to be 0, and 0 times, who cares what that is, 0 times anything would give you a 0 denominator, so it would be no good. But we've got another restriction right here, so we got to solve that one. 2a minus 3 cannot be equal to 0. So if we solve this one, we see that 2a cannot be 3, which means a cannot be equal to 3 halves. So there are our two restrictions. Can't be negative 3 halves, can't be positive 3 halves. Any other number for a is fine, but it can't be either of those two. Well, while we could find the restrictions right away, it's better to just wait until it's factored, and then we'll grab them at that point. It's a little bit easier. 2x to the third minus 5x squared minus 3x over 8x to the fourth minus 2x squared. We got to start out by factoring. Do the top and then the bottom, or the bottom then the top if you prefer. So let's take a look at the numerator. Factoring. How? Plug in x and we're left with 2x squared minus 5x minus 3. What about the bottom? Now note that the top isn't completely factored, but just for the sake of not having to go back too far, let's factor the bottom also. What can we do here? 2x squared. So 2x squared times 4x squared minus 1. Okay, now we can factor more, but that's a start. So we have x times, we have a trinomial here. So we want to check and see how this thing will factor into two binomials. Now here, you could do trial and error, or you can use the factor by grouping method. Take just a minute and factor that. I'm going to jump over here and factor it over here also, but take just a minute and see if you can factor that. Familiar? Okay. So then we know that this factors into 2x plus 1 and x minus 3. Okay, well, the bottom will factor a little bit more easily. 2x squared times what? Two x and 2x, it's a difference of squares. Plus 1 minus 1. Okay, so now it's completely factored. Now we can answer both the questions. Now we can simplify it and we can note the restrictions. Before we simplify, let's just go over here and note the restrictions. How many restrictions are you going to have on this one? 3 of them. There's going to be 3 restrictions. First of all, we have to note that 2x squared can't be 0. It's an easy one to miss. Well, if 2x squared can't be 0, what's the solution to this? X can't be 0. Okay, so there's one restriction. X can't be 0. Then the other one, 2x plus 1 can't be 0. From this guy right here, 2x plus 1 can't be 0, therefore 2x cannot be negative 1, subtracting 1 from both sides, and x cannot be negative 1/2. There's our second restriction. And our third restriction, 2x minus 1 can't be 0. Add 1 to both sides and we have 2x cannot be equal to 1. So x cannot be equal to 1/2. So there's our 3 restrictions. Too easy to miss this one. Don't forget that that one is a restriction also. All right, well now we can answer the final question. We got our restrictions. Now simplify it. What have we got for common factors here? Just 2x plus 1. You can knock an x out of there. Okay? We can get rid of that x, and we can get rid of that x. That's better. So, in our numerator, all that's left is x minus 3. The denominator, we have 2x times 2x minus 1. X minus 3 over 2x times 2x minus 1. That's simplified. And there's our restrictions. And we're done. All right? Let's take 15 over 16 times 12 over 25. Okay. If I put that problem on a quiz, what would you do? Yep, you look for common factors. You cancel common factors diagonally. So, for example, we look to the 15 and the 25. Is there any common factor in both of these? Common factor of 5, so we can cancel that out. This 15 is really equal to 3 times 5, right? And that 25 is really equal to 5 times 5. Since we have a 5 in the numerator and the denominator, we can cancel out one of those 5s, okay? The 16 and 12. 16 is really equal to 2 times 2 times 2 times 2, or 4 times 4, and the 12 is really equal to 3 times 2 times 2. So after you've factored it, you cancel out common factors. We can get rid of a pair of 2's, or in other words, 4 out of each of those. And now what we're left with is 3 times 3, which is 9, over 2 times 2 times 5, which is 20. Now, as long as we've canceled all of our common factors, this won't reduce. If we missed a common factor somewhere, then it would reduce more. It's either cancel now or cancel later. Either you cancel back here when they're factored, or if you miss one, then you'd have to reduce this and cancel later. But since we got them all, that's it. We're done multiplying. We found the product. So that's what we're going to do now, but with algebraic fractions. We factor them, cancel, and then multiply across. What about division? 3/4 divided by 7/16. That's really the same problem as 3/4 times 16/7. Remember, dividing by a fraction is the same as multiplying by the reciprocal. So 3/4 divided by 7/16 is the same as 3/4 times 16/7. So here again, 4 and 16, we've got a common factor there. We could rewrite the 16 as 4 times 4. We can cancel off one of those 4's. And we're left with 3 times 4, which is 12, over 7. Now we could make that an a mixed number. But because we aren't going to convert fractions to mixed numbers, we'll just leave it there. We've shown the process. Okay? Look familiar? Let's find this product. Well, the first thing we need to do is go ahead and factor everything. 5x minus 1? Can't factor, you say it's prime. 5x minus 1 stays just as it is. X squared minus x minus 2? We like it when the coefficient is 1 because we know it's got to be x and x. Minus 2 plus 1. Everybody agree? Okay. Over here we've got x minus 2, won't factor, over just to save you a little bit of time, to save us a little bit of time, I'm going to tell you how that factors. But it's a trinomial. We could use this same method we did over here to factor that, and it factors into, what does it factor into? There it is, 5x minus 1 and 2x plus 3. Now something to watch for whenever you're doing these problems, a little tip. These problems are written just to make good math problems, all right? They're written so that you have some canceling to do. So even before we filled this in, you should be suspicious that 5x minus 1 is probably going to be one of your two factors down here so that it'll cancel. If you do all your factoring and there's no canceling, be suspicious. Could happen, just not likely. Okay, well, we've got everything completely factored. Now we can cancel common factors diagonally. We already noted that one can go. We could note the restrictions here, but we're not going to. We're going to leave that now until later. But that cancels. What else? X minus 2. And that's really about it. And so we're left with our product of, in the numerator we have 1, and in the denominator we have x plus 1 times 2x plus 3. We're done. Any other questions about that one? Okay, one more of these, and then we're going to go on to the last topic here. Trial and error, that's left over. I changed the slide from yesterday when we were factoring. This is, it shouldn't say trial and error up there. Well, what we really should do first here, is rewrite it as a multiplication problem, okay? So that we don't forget to flip this thing over. So let's rewrite it as a multiplication problem. This becomes, we could factor it at the same time, and in reality that's a good idea, but just to make sure that we don't overlook anything, let's do them as separate steps. A to the 5th plus 4a to the 4th plus 4a cubed over 6a squared b times 9ab to the 3rd over a squared minus 4. Okay? Now we can factor away. Now a to the 5th plus 4a to the 4th plus a cubed. We can factor out a cubed. And that leaves us with a squared plus 4a plus 4 now that'll factor a little bit more, won't it? It will. What's that going to factor into? A plus 2 times a plus 2. Just because I'm running out of board space, I'm going to put that right in the same spot. Now that we've seen how it's going to factor, we're going to write that as a plus 2 times a plus 2. I don't have quite enough room to write that as another step, so we'll do that all in one shot. Down here, there's really nothing to factor. Anytime you've got one term, it's pretty much factored the way it is. Okay, so we've got 6a squared b times, let's go over here, 9ab cubed over a squared minus 4. Now here again, be suspicious. You've got factors of a plus 2 up here. Probably going to have a factor of a plus 2 down here. And that factors into a plus 2a minus 2. Okay. Now, just note what the restrictions are. From over here, a couldn't be 0, because that would leave this whole denominator being 0. B could not be 0. You've got restrictions on 2 variables. Over here, a couldn't be negative 2. A couldn't be 2. Again, not that important right now. We'll come back to that idea, though. So now let's cancel off. What do we have here? We can get rid of those. What else? We can pull out a 3 out of both of these, so that 9 and 6 will both reduce and become, if we divide them both by 3, 3 and 2. Now some a's. Down here we've got a squared. Up there we've got a to the 3rd and an a. We can just cancel 2 of them off. Get rid of those, and what are you left with here? Just one a left up there. A to the 3rd over a squared is just one a. It's a property of exponents that we did a little while ago. And we can cancel off a b. We can get rid of this b. And we can cancel off one of these b's, and so that's b squared. So, common mistake is to, after you do all your canceling, miss something in all your scribbling and lose a factor here. So be very careful when you go and pull these out now. So what do we really got left? We've got, first of all, our constant is or our coefficient is a 3. What about powers of a? A squared. There's one left here and there's one right there. So a squared, b squared times a plus 2 over down there 2 times a minus 2, and we're done. Nothing more to simplify. Okay, so we can multiply and divide fractions. That leaves us with one more little odd thing to wrap up here. You okay with that division? All right. Last thing then, what is a complex fraction? These are also often called, and better called, compound fraction, but your book refers to them as complex fraction. Basically, a complex fraction is a fraction where you've got a fraction within a fraction. Like that. That's an example of a complex fraction, a fraction inside of a fraction, where your numerator or your denominator, or in this case, both, is itself a fraction. Now, there's really two techniques for simplifying complex fractions. The way that's usually easiest is just to find the LCD of all your fractions and multiply the numerator and denominator by that LCD. That'll clear it out and simplify the fraction. It's not the only way, but it's usually the easiest way. Let's simplify 1/2 plus 2/3 over 3 plus 1/4. Now, ultimately, keep in mind what we could do here is we could figure out what 1/2 plus 2/3 is and divide it by 3 1/4. That would work. That's the alternative method. We'll do one of those at the end. But what is usually going to save you time with algebraic fractions is just recognize what is your LCD and multiply top and bottom by the LCD. So if you look at all the fractions that show up here, 3 over 1, 1 over 4, 2 over 3, and 1 over 2, what is your LCD of everything you see? 12. Everybody agree? 12 is the LCD of the whole works. Now we're going to multiply the entire numerator and the entire denominator by 12. And if you do that, and if you've chosen the right LCD, you'll have a simple fraction. It won't be compound anymore or complex. So we got to distribute this though. 12 times 1/2. What is 1/2 times 12? 6. Plus 2/3 times 12. Now what is 2/3 times 12? 8. That's 24. 2 times 12 is 24 over 3. 6 plus 8 over. Okay, we got rid of the fractions in the top. That's good. In the bottom we have 12 times 3, which is 36, and 1/4 times 12, which is the same as 12 over 4, plus 3. Let's stop there for a minute. Everybody see where the 6, the 8, the 36, and the 3 come from? If you've chosen the right LCD, Grant? The 8 is from taking the 12 and distributing it right here. So if we take 2 over 3 times 12 over 1, you get 24 over 3, which is 8. Okay? Okay, well then you're basically done because you end up with 14 over 39. That can't be reduced. End of story. So we annihilated it by using the LCD. Well, what's your LCD? 7D. Not to be confused with 70. 7D. Okay, so let's multiply the entire numerator and the entire denominator by 7D. So, take the 7D and distribute it over this first term. What does that first term become? ABD. Everybody agree with that? Your 7's in the first term would cancel. Okay, then let's multiply it by the second term. What does this one become? 42d times d, 42d squared. Yep. The denominator, we're going to take 7d times 3c, we get 21cd, minus 7d times ab over d, 7ab, the d's would cancel. Okay, well, it worked. We got rid of our fractions. Now it's a simple fraction. There's no fractions inside of it. Now the only thing we have left to do, this is true, but we should take this one step now, and we've got some common factors. Common factor here of d, and so we can rewrite this as d times ab minus 42d over, here we got a common factor of just 7. 7 times 3cd minus ab. Why would you do this last step? Why would you do this last step of factoring? What's the benefit of doing this as opposed to just leaving it right here? So everything's factored out. Why would you want it factored out? Check and see if there's anything that cancels. These don't match, so they don't cancel, but that's just this case. They could have. In this case, they didn't. All right. We're going to factor everything first, okay? So there's our top fraction. I'm just going to tell you, to save a little bit of time, that x cubed plus y cubed, that's going to factor, right? It's a sum of cubes. So that top value of x cubed plus y cubed is going to factor into x plus y. And what's the other part going to be? X squared minus xy plus y squared. Good, that's done. X squared minus y squared, the denominator at the top, that's going to factor, right? X plus y times x minus y. Okay, now let's jump down to the denominator. X squared minus xy plus y squared, that won't factor. If we had more time, I'd let you stare at that for a while and try, but it won't factor. Okay? And the denominator of the bottom, that's going to be x minus y, that will not factor. So tell me, what is our LCD? X plus y, x minus y. That's our one denominator, and here's the other denominator. So x plus y times x minus y will be the lowest thing that they'll both go into.
But would it on the top, the x plus y cancel? Can you just take them out and start canceling right away?
Sure. Okay, good. Let's do that. You want to cancel these?
Yeah.
Good. I don't blame you. Okay, so now what's your LCD?
Take that bottom fraction, the denominator, and take it out and flip it.
That's the other way to do it. That's right. You could now take this thing, flip it upside down, and multiply it by the top. Right? And you're going to get 1. We could say this is the same as multiplying it by x minus y over x squared minus xy plus y. Absolutely legitimate way to do it. Your alternative is to multiply them both. Multiply them both by the LCD, which is x minus y, and this is just beautiful. What do you get? What happens here? They cancel. How about these two? And so you're left with x squared minus xy plus y squared over x squared minus xy plus y squared. Now, we can't cancel term by term, but we can cancel the whole doggone thing. Any fraction where the top and bottom are equal is equal to 1. And you're done. Okay? So those are the two methods for simplifying compound fractions. You can either take the denominator and flip it and multiply, or you can multiply by the LCD. Usually the LCD method saves you some writing and work. Not always.